here, and we got to work on the project now. Let's see if I can't get something going here. But still, there are many other ways to represent numbers. For example, when working with computers, you'll deal with binary, octal, hexadecimal. It's really nice to have a tool that can easily help you correctly convert the numbers from one system to another. In this project, we will build such a tool step by step. In the first stage, you need to implement conversion from decimal to binary, octal, and hexadecimal. The program will read the user's decimal number and the user's target radix or base. Then it will output the given number in the corresponding base. The conversion algorithm. Wow, look at this. Got it. This should be interesting. Okay. So I've done this binary before, and the way I did it, I actually liked it. What's the max input? Does it say? I'm just trying to think. Let's start with like fun. So we're always going to start with decimal. And then like if we convert to binary, so this will be let's do a string. We're going to do string representations of this stuff. So in the past, right, what I've done is like you can get 0, it's 1 equals 1, 2 equals 0, 1, 1, 0 actually, 3 equals 11, 4 equals 1, 0, 0, right? It's like this. so what it also looks like is this. And so what you can do is subtract, oh, that's right, I had a list. So val decimal equals list of, and you can do like your max. Oh, maybe you could do that. Let's see here. Let's get 4, right? So we'll have 5, 6, 7, 8. I have an idea. I don't know if it makes any sense though. So let's see. This is 101, 110 equals 111, and this would equal 1000. And we can basically go to 15, right? And then we end up with all ones. So 8 plus 4 is 12, plus 2 is 14, 15. Right, and then this all needs a 0. I want to see something real quick. If I can't scale this, like what if I could do 4 bytes of 4 at a time out of a number, and like get, I don't know if that makes any sense though. I have no idea. Let's see. So 8, 9, 10, 11. Fuck. 13, 14. Yeah. Okay, let's fill this in real quick. So this is 8, 9, 10, 0, 1, 1. I think it's like that. Okay, good enough. Let's do this. And now let's think of an example here. So, well, we don't even have to think of an example. What if we had, we need an example, hold on. So if we have 16, right, equals, let's just do this real quick. 1, this is 16. But what is this also? Oh, that's how you do it. You divide by 2. Now I think I'm remembering now. So you do, and the number of times you divide by 2 is the number of spaces you need, I think. So like, watch this. So if I take 2 equal 2 divide by 2 equals 1. Now let's see, 4 divided by 2 equals 2. But I'm looking for the number of spaces. I wonder if this even makes sense. Am I just like inventing something that doesn't make any sense? I mean, this technically worked, right? There's 2, I need the second spot filled. Like this should be 2 binary digit representations. 8 divided by 2 equals, what is that? That's 4. And 6 would have been 6 divided by 2 equals 3. So far, so good. But how does 5 work? Maybe you always round up? Does that make... No, 4... Oh. 4 divided by 2? Oh, it doesn't work. I don't know what I'm talking about. Or maybe it's just always plus 1. So 8 requires 4. I think I'm just making something up that doesn't make any sense, to be honest. What I'm trying to do is see if I can have like a way to represent any binary number. And like an algorithm that doesn't have... So what I've done in the past is like I basically did this where I did like 16, it would be 16, and then 15, 14, and then you have... No, you wouldn't do each one. You would do 16, 8, right? Yeah, 8, 4, 2, 1. And then you would add ones depending on the spot. Like he would subtract from the number. But the point is like I have to... I think I'm seeing it. I think I see it now. This is it still. Okay. Okay, so watch. We'll hard code it and then I can show what I'm talking about. This is exciting because I think I got it 1, 2, 3, 4, right? So like, let's just tab this over. Oh, list of. Right, so not the best way to represent this, but okay, check this out. That's 16. This next one's 1,000, right? Okay, so what happens here? This is times 2. This is times 10. You start at 1. Okay. So that means I can scale up until the number is bigger than the input. I can track the starting number here, and then I just have to divide by 10 and divide by 2 for the next one to add to the representation. Yeah. That probably doesn't make any sense, but let's imagine val start equal decimal start equals 1, val binary start equals 1, right? And then what happens? Times 2, no, this is decimal start, I said. Okay, times 10 times 2. And now while decimal start is less than n, wait, am I doing this right? Hold on. The naming is weird. Basically, this is... How do you represent binary, 1 and 1. If I go to 2, it's 10. If I go to 4, it's 100. If I go to 8, it's, yeah. So as long as I'm doing this, okay, so I think this is kind of confusing me. Get rid of it. Okay, so these are vars. And now, oh my god, can I, times equals 10, binary starts times equals 2. Okay, so at the end of this, what do I have? I have where I need to begin, and then what's cool about it is like I can use the technique I used before, but instead of hard coding them, I can just use division, I think. So var output equals 0. While output I'm just trying to get my head wrapped around this. Oh no, it's, oh, that's it. Turn output, and then you don't start here, you start output should be our binary. I don't know what this is yet. But this would be binary number. Oh. Var. Oh, there we go. So if n is 0, look, there it is. I think this is it. And now you do n minus decimal rep. I don't know if max makes sense either. It's like, This also doesn't quite make any sense. I'm doing this backwards. I am doing this backwards. This is backwards. This is why it feels off, I think. So decimal and then binary. Binary is the right side, decimal is the left side. So this is decimal, this is times equals 2, and this is binary, and this is times equals 10. I wonder if this is powers. Is that what I'm doing? Whatever. So let's do this, and then equals n. Minus equals decimal. And now, when I do this, I need to decimal. Like, why can't I spell? Divide equals by 10, and divide equals. No, this is divide equals by 10. This is by 2. I think that's it. Let's see if I can make this work. Let's throw a little print lines in there. Right now, we'll just do this is all we care about for a second. Okay, let's give it a crack. Hopefully there's no infinite loop here. 101. Wrong. Fuck. Okay, so I mean, let's throw some things here and just look at this. N's 101. So while decimal is less than 101, okay. Binary goes to 10. Still true. 4 and 100. 8. Is 8 1000? 8 is 1,000. So we're good so far. 16, 10,000. 32. Oh. I think that's right. 64. 128. Ah, okay. It did one too many. That's all. And we can fix this easily. Okay, so stop. It just did one too many. So at 64, that's when we need to say, okay, so while true, if decimal times 2 is greater than n, break. That should handle it. Let's try again. 1, 2. I don't know why I put this here. Why wouldn't I just put it up there? So we go 8, 16, 32, 64. Cool. And now conversion result. Still wrong, but seems interesting. Okay, let's just fix this real quick. So, alright, that should resolve this up here. Now, what's going on with the next part? Let's see. Let's close this. So decimal representation is 101. This is 0. Makes sense to me. 64. This all makes sense to me. That's what? Yeah, okay. Now we break it down by 2, and that should, the next one should be a valid representation. So we have 37. 1, 1, and then what was the answer? Look, it's 1, 1, 0, 0, 1, 0, 1. Okay. So there's only 5 left, so it shouldn't. Oh. What happens here? I see now. Doesn't make any sense. So there's a little bit more work to do here. Oh no. How do I do this? This shouldn't happen all the time. This should happen. Right? So binary representation minus decimal. So this decimal is 16. No, this shouldn't happen all the time either. Sorry, this should happen every time. This should not happen every time. So I need if but we should do it every time, I think. Let's see. All right, here we go. False. So we need to divide by 2, which should give us 8, which would put 0 there. Next, we're still not there. 8 is still greater than 0. Now we're at 4. That looks nice. 4. We had 100. And now 2 doesn't work. 1 does work. And decimal representation is not greater than 0. Oh! You love to see it. That was a good session, man. With time to spare. That was cool. So, I'm sure I've seen the implementation before, but I've never actually done it myself. So, to actually like work it out and see how it worked, that was pretty legit in my opinion. We can get rid of this. I'm pretty confident this will work for any number now. In fact, let's test it, right? Or here, we'll do this. ChatGPT, can you, if I can spell, no, like as ChatGPT, can you, oh, there's something else to do here. I just had an idea. No, like it's, so let's try our own number here. Let's do 1993. And it's 2. Oh, that does not look right. What happened here? How did I get an 8? What? No way. How did this happen? What? How could this happen? I don't understand what just happened. How am I getting numbers that aren't possible? Oh, it's too large. Okay. What if I make this a long? Or no, that's too long. What happens now? looks a little better. Sorry. Let's see what it gives me now. One, two, three, four, five. 1001. 1, 2, 3, 4, 5. Okay, cool. So I'm handling bigger numbers now. Nice, nice, nice. Okay. Okay. So as I was looking at this, I realized, right, that well, I don't know. I'm wondering if this can be, if I can represent, like I wonder if my convert function could be generalized so that it doesn't matter what base I put in, I pass in the base and it figures it out. The hard part is figuring out how on earth to do this. So I'm gonna run out of time here, but I don't want to forget this. So imagine, right? It's like something more like fun convert, and then we do like n long base int. We'll just call it long 2, and then representation. I don't know why it's capitalized. Let's just do rep for a second and do, it's like a list of string, right? How do we show specific characters? Like what I'm imagining is for hex, how would I represent that? So how can I do this without decimal and binary here? So we definitely need n long. We're gonna need both of these. Like, see how I have times 2 here and times 10? I mean, what if this was times 8 for octal, I think, and times 16 here? Like, this should be configurable so that we can do whatever we want. So this will be, I just don't know how. So like 2 equals 10, 4 equals 100, right? So this was obvious to me. Now, if I did hex, 2 equals 2. See, I don't think I can do this. 4. So you times by 2 each time. But I think you would do 16 actually. Oh, I think that's it. So 1 equals 1. 2 equals 2. 16 equals f, right? And you would place does that mean I need to, oh, interesting. I would be dividing by subtracting by 16 every time? I'd have a lot of F's in a row. What about, can you convert numbers to hex? Let's see. Or here, is there an example here? Not a very fucking good one. What is that? Oh. Okay, I think we need to look at the theory. I think there's a way to do this, but I don't know. I need to sort it out, you know? Here, let's go look at it real quick. Oh, 15. This is wrong. Also gives me another idea. What if, so 15 equals, what if I convert everything to binary? Does that help me at all? I just don't know why I would. There's something here. I know I can do this. And then what was the octal? Oh my god, dude, I hate when they do that. Come on, where did it go? What's going on here? Why can't I find? Why can't I search in my own browser? Come on. Do you see this? I don't know what's going on. Oh, it's down here. Oh my god. Like, what? You see? there's something here where every decimal goes into binary and then everything comes out of binary. Because I mean, look at this. This is honestly easier than doing it the other way, I think. So I don't know, we'll explore it tomorrow. But decent session. I enjoyed that.